Everyone. Thank you for joining us today for the 2021 Urban Landscape Summit. We are getting close to wrapping up our summit, and my name is Wendy Wilbur. I am the State Master Gardener Coordinator for the University of Florida IFAS, and I work for the Center for Land Use Efficiency. And today I've been asked to fill in for Dr. Michael Dukes, who is away, and I'm going to be introducing our speakers today. So if you are attending this training for CEUs, make sure that you registered accordingly for that. And remember that all of these presentations are recorded and will be available to you to see even with closed captioning. So that is a possibility if you need to see later. All the questions we asked you to put in the chat box, and I'll be moderating the chat box and providing those questions to our presenters once they are completed. So today we have Dr. Eban Bean and Kevin Coyne, and they are joining us to present on Compost Amending New Residential Landscapes in Florida, Research and Policy. And we're going to start with Dr. Eban Bean, his presentation, and then Kevin Coyne is going to answer some questions later. So I'd like to go ahead and fill you in a little bit about Dr. Bean. He's an assistant professor and extension specialist of urban water resource engineering at the University of Florida. He's in the Ag and Biological Engineering Department, and he's also a faculty member for the Program for Resource Efficient Communities and the Center for Land Use Efficiency. Dr. Bean has been working in urban hydrology and water quality for the last 15 years. Prior to his current position, he was assistant professor of environmental engineering at East Carolina University and a senior staff engineer at Geosyntech Consultants in Georgia. He received his bachelor's and master's from North Carolina State University and received his PhD from University of Florida in Ag and Biological Engineering in 2010. And we're so glad he's with us today. And we also have Mr. Kevin Coyne. He's been with the Florida Department of Environmental Protection since October 2014. He is a program administrator for Basin Management Action Plan, lovingly called BMAP program. Prior to his start at the department, he managed the West Virginia Department of Environmental Protection's Water Quality Standards Program. And he also spent time working on various total maximum daily loads, TMDLs, and non-point source issues in California and Maryland. He has a BS in Wildlife and Fisheries Management and a master's in Public Administration. And he's also working on another master's in Aquatic Environmental Science program. So I am so glad that you all can be here for the Urban Landscape Summit and present to us on compost amending in residential landscapes. And with that, Eban, please get us started. Thank you.
Thank you very much for that introduction, Wendy. It's great to be here today, although it'd be great to be in person. I think this has been a great way to continue the Urban Landscape Summit in these trying or unconventional times, so to speak. So yes, I'm going to be speaking today along with Kevin Coyne on sort of some of the work that we've done on amending new residential landscapes and the policy implications or some of the policy related aspects of that during our time today. Get everything, there we go. Just want to give you sort of an overview of the presentation that I'm going to provide. First of all, we're going to sort of start with a background on soils and urban landscapes, just to get everybody up to speed. We've been doing this work for a while. I imagine some of you have seen some of this work, but just want to make sure that everybody kind of starts at the same place as we get into that. We're going to go over briefly some of our past research projects, and then provide some of the new material that we've had from a new project over the past year or so. And then we'll provide sort of a summary of some guidance documents and other resources, and then kind of cover some policy resources and discussion. And then we'll have some time for Q&A for Kevin and I. All right, so let's go ahead and get started. All right, so just to get started here, in Florida, we have gotten really good at doing urban development, residential development in particular. If you've noticed, it takes almost no time at all, it seems like, for flat lots basically to become homes. And to put a number to that, it's really along the lines of 65 days. is what we hear from the development community. So today is March 17th, so we would be talking about by May 22nd, we could go from a flat lot where there's nothing there to a fully completed home ready to move in. During that time period, there's not a whole lot of downtime. So there's a lot of activity that's going on during that development process, during that construction process. There's a lot of vehicle traffic on the site, and there's a lot of basically activities that lead to basically compacting the soil in the residential lot. Now, one caveat here, it is important to have sort of a stable foundation for the home so that you have a foundation that is solid and stable and not shifting. However, when we get into the land, when that extends into the landscape, it can have some long-term implications for the quality of the landscape as well as our water resources. So during those 65 days, during the construction process, we have three things that really combine to compact the soil: heavy vehicle traffic, the wetting and drying process, which I'll get into a little bit more in a moment, and vehicle vibrations. Basically, engines that are left running, that vibration translates through the tires into the soil, just the regular activities, or whether it's a piece of larger, heavy equipment. Now, this graph kind of shows the relationship between, on the y-axis or the vertical axis, the soil bulk density, okay, how compact the soil is, if you will. And then on the x-axis or horizontal is the water content, how wet that soil is. And each of these lines here is a different soil texture. The soils that we deal with that are well drained and sandy soils tend to be sort of up in this range here. Now, the reason that the wetting and drying and heavy vehicle traffic on a site is so detrimental or compacts soil so well is that there's two sort of limits to compaction in this situation. So if you look at each of these lines, it's essentially a hump, right? So on one end, you have the dry end. If you go to the beach and you try to compress sand, it really doesn't compress very well because of the friction between the particles. It just doesn't go together. You don't reduce a whole lot of space. And then on the wet end, once we get enough water, we get too much water in that soil, well, water is incompressible. And so what happens is that basically limits our compaction. So what you'd ideally want is wetting and drying, frequent sort of rainfall events, if you will, and then daily sort of drying out, and then vehicular traffic on the site that basically optimizes that compaction. And so that's kind of what we have going on in a lot of our residential landscapes. So what are the effects of soil compaction? Well, the compacted subbase, a lot of times that soil that's compacted, sod and other vegetation goes directly onto or into it. I'm sure you've probably seen examples where either maybe a tree has been planted in the right-of-way or sort of that space between a sidewalk and a street where it's been there for 4, 5, 8 years maybe and hasn't really grown. More than likely, that's an issue with soil compaction where that root ball really can't get out of the initial planting and access a broader amount of soil for water and nutrients to take up and cause it to thrive. Same thing kind of happens in turfgrass, where if you've ever seen the carpeting effect, where you can kind of you've seen it just kind of pull up where the roots have not gotten contact with the soil. So there's lots of detrimental or several detrimental aspects to soil compaction. The less infiltration we have less infiltration that occurs leads to more runoff. We know that stormwater runoff is a major source of transporting nutrients and other contaminants in our water bodies. It also can limit the rooting depth. So as I was talking about with the turfgrass, not being able to anchor roots deep into the soil. By limiting the root depth, it prevents the roots from actually getting deep in the soil and actually decompacting the soil. So it's not just inhibiting the plant growth, but the function that mitigates it as well. This causes the turfgrass overall to be less drought tolerant, more sensitive to those dry periods, and require or rely on usually more frequent watering. And just to put it in perspective, we estimate that in 2020, public supply in Florida was about 2.6 billion gallons per day. And we expect that to go to about 2035 to go up to about 3 billion gallons per day. Back in 2015, the USGS estimated that domestic consumption or the residential portion usage of that, is about 1.5 billion gallons per day. So if we assume that half of the residential use of water goes to landscape irrigation, which is commonly a stat that's mentioned by water management districts, we're coming in somewhere around 750 million gallons per day for residential irrigation. So that's a lot of water. And so this is one of the main drivers for this research on amending residential lawns. I want to take a moment and go through sort of a couple of the past research studies that we've had that really set the stage for a lot of the work that we're doing now and some of the guidance that we have. Back in 2017, we started a project with On Top of the World, which is located in Ocala, just kind of in the southwest portion of Marion County. And as you can see here, the Swift Mud average water usage is about 250 gallons per home per day. Well, On Top of the World, which is a active adult retirement community, if you will, they wanted to be much more conservative with that. And they agreed to 150 gallons per home per day as part of their water use permit. And so they were getting their water usage down pretty low by, maxing out on the indoor efficiencies. And they were even doing Florida Water Star, but they still weren't getting to 150. They were still somewhere in that 180, 190 gallons per home per day on average. And so that started a relationship with IFAS and with some of us to start and look at, can we improve the soils to reduce irrigation here? So right now they're at about 6,000 homes with a build out projected eventually somewhere in the neighborhood of 30,000 homes. So it's really important that they continue to meet their water consumption goals as their community grows, so they can continue to be granted more additional water supply as they grow. So this was the first study. We were able to come in on a model home study or a model home situation. We have 10 homes here. And in our study, we used all but this last one. And that's mainly because this one has sort of an odd site on the lot, and it ends up having a very small backyard and front yard. And there wasn't as much to do to be able to do there. So one of the nice things here was that we had no homeowners, but it was just like the real world. That's basically as good as it gets in some cases. So we took 9 of those homes and we left 3 of them right while they were under construction. We left 3 of them, the lots, the soil was left compacted. 3 of them, we took 4 cubic yards, which is pretty standard application rate of compost. And in this case, we were using the Command product provided by Life Soils. And we incorporated that into the top 6 inches of the soil. We also wanted to look at how tilling the soil without an amendment might improve the soil properties. So one of the aspects being, if we don't have to deal with an amendment coming into play or managing that on site during the construction process, then we would probably have much more transfer into application or into practice than if we had to deal with an additional amendment. Just a few notes here. We did this incorporation or tillage just before they laid down Empire zoysia on these lots, and it was just before they installed the irrigation lines. So you can't go about and till the site with irrigation lines in place. One note as well, one more note, these sites here were all treated uniformly. They all got the same irrigation scheduling. They all got the same landscape maintenance as far as herbicides, pesticides, and mowing schedules. Okay, so the only thing that was different here is the tillage and the compost incorporation that happened just before the sod went down. So looking at the water holding capacity, or sort of the water availability in the soil, soil is kind of like a sponge. If you take the sponge off the counter and run it underneath the water faucet, it's going to loosen up and you're going to get it saturated pretty quickly. You pull that sponge out, it's not going to hold on to all the water that's in it as it was kind of underneath that faucet. Some of that water is going to drain out pretty rapidly. and just basically instantaneously. And so in the soils, we have that similar function as well. This is basically what is represented by the blue bars here, or the water content or the porosity that is not available to plants because that water basically drains through so quickly. Basically within 24 hours, that this amount of water would be in the soil and then gone the next day. And then if you try to take a sponge and squeeze all the water out of it, there's going to be some amount that you just can't get out, all right? And the soil is like that as well. There is basically a certain amount of water, and this is made up or basically represented by the orange bars here, the volume of water that is held so tightly by the soil that plants cannot extract it from the soil. And so what really kind of matters, or what to the plant, is the water that is kind of in between those two, this green part, known as the plant available water. And so one of the things with this study that we wanted to look at as well was, well, compost is organic. You know, how long is this really going to last for? And if there is any benefit? Well, number one, there is a benefit, and we saw that, you know, time and time again, we did this 3 times during this study, that the compost amended soils were essentially had double the plant available water as the compacted or null soils. And what was somewhat surprising was that the tilled soil ended up being very similar to the compacted soil. And at first I was surprised by that, but if you think about sort of a sandy soil, there's not much structure. And then after you fluff it up with tillage and then put sod down on it, water it in, you know, go through that a little, let it, you know, kind of settle down a little bit, it basically reconsolidated back to that pre-compact state. And so we didn't see much benefit from just tillage alone. There was a need for there to be an amendment that got incorporated. Okay. And so with this, we saw that after 22 months here, that the compost amending still, that initial compost amending still had a benefit to the soil to reduce the, to increase the plant available water. And I'll just I usually use this as a quick exercise just to kind of show the benefits that you can kind of see. This is actually a little bit further. This is more like, let's see, I think this is, let's see, do the math, almost 30 months after we did the initial incorporation. And so one thing I'll show you is that, you know, along this back row, we had two tilled lots, 1 compacted and 2 amended lots, or 2 compost lots. And so think to yourself, which ones would you say are the amended lots? Hopefully it's pretty easy that you can find this out, or kind of figure this out, that, you know, here are tilled and compacted, not much difference in the turf quality around the home. And the amended, it's just, you can just tell a difference within the soil health. This is the third one. You can see it's a little bit darker, but with the shadow, it's a little bit harder to pick out. But the compacted tilled lots, you know, still same thing. You can kind of see the difference there. All right. So based on that, we did some modeling and basically showed that we should be able to reduce the irrigation by 25% for compost amended lots without impacting the turf quality. All right. So we've continued to work with On Top of the World, and basically extended into the area that the model homes were serving. So here's our model home study area, and then we moved into this area in the back. And we took 24 of these homes, 7 of which were composted, amended, 8 that were tilled, and 3 that were left compacted. So similar, I'm sorry, 9 that were left compacted. So similar to the same treatments that we had in the previous study. We also asked all of the homeowners to reduce their irrigation run times by 25%, with the caveat that they could return it at any point during the study, or adjust it however they wanted, based on, you know, however they wanted to manage it. Just start with a 25% reduction. So these treatments were applied before the landscaping went in, before the irrigation lines went in, and they used zoysia grass as well. Command was also incorporated here at the same rates, 4 cubic yards per 1,000 square feet. We also top dressed this half of the lots twice per year. I'm not going to get into that aspect very much here. Essentially, we saw very little effect of the top dressing And a lot of that is because many of the parameters we were looking at tended to be more on the physical side of the parameters rather than the specific water quality side or the biochemical side. So we looked at several aspects of the water balance in this site. We measured the runoff volumes, and that's why our homes are kind of clustered rather than being randomly situated here. We had to basically instrument the inlets here. That's what these white ovals are with numbers. We had 8 of those, and we basically measured the runoff rates, volumes, as well as nitrogen and phosphorus concentrations. Half the homes we put in soil moisture sensors to look at how the volumetric water content changed and basically what the typical water content was in the soils. And we had data on whole home water usage, as well as some of the irrigation water usage. I'll share a little bit more on that in a moment. And in each home, we also installed lysimeters to look at the volume of leachate that was coming out of the soil, as well as we analyzed that for total nitrogen and total phosphorus. Just to kind of cut to the chase with this study, there were, we had the 3 treatments, and there were, within each treatment, the homeowners kind of fell into one of these 4 categories, okay? So we have sort of the standard, those folks who stayed at that 75% runtime or the 25% reduction. We had some folks who decreased it further, some that returned it to 100%, and some that actually increased it above 100%. All right, for the control lots, by the end of the study, we saw that of the 6, half of them stayed at that 25% reduction. 1 returned it to 100%, and 2 actually returned it to above 100%. And this is sort of what we expected to happen, that there would be a proportion of that these homeowners would be likely to either stay or move up to that 100% full runtime because their turf grass would suffer maybe, and they would need to increase their irrigation. The tilled lots, we had 2 that decreased their irrigation to less than the 25%, 2 that stayed, and 1 that returned their irrigation back to 100%. And then with the composted lots, we had 3 of the 4 that we had data for that decreased their irrigation even further. They basically reduced theirs by 55%, their run times for their turf grass areas. And this was at no encouragement on our part, or any kind of interference or suggestion on our part. They did it on their own. This one, when you're dealing with homeowners, some homeowners are going to do what they want, no matter what you educate them with. This was kind of the case we had here. This guy's landscape was immaculate. It was basically like a pro sports field. It looked fantastic. I mean, even though he had, the compost amended lot, he basically did all that he could. I failed to mention initially that one of the aspects here is that we didn't tell the homeowners what had been done to what treatment they had. So it was, they weren't aware of what that treatment was, but, even with having really great turf grass and having a high quality lawn, this homeowner still wanted to use as much water as he was allowed to. So we had sort of that change where, we had more of a proportion of the compost amended lot homes decrease their irrigation on their own. And then we look at the volumetric water content, the top row, or the dark lines here, the black lines here, basically show the water content for the compost amended soils. You can see that these are, basically kind of between the 15% and 35%. And you kind of see that once they get moist, they kind of stay up there for a long time. They don't drop very quickly. They provide a lot of water. They maintain that high water content. And then when we get to the tilled, it's kind of a split here, where some of them held on to water a little bit longer, similar to the compost, but some of them kind of had more of a longer or a quicker drawdown than the other 2 sites. And then with our control or our compacted soils, we see most of these lots, we see a very sharp increase when we have a rainstorm. All these happen at the same time, indicative of rainfall. Rainfall spikes that water content, and then it drops off very quickly, and we maintain sort of this lower water content, and thus we have sort of irrigation event or another rainfall event. Okay, so just looking at the overall water content, the compost soils also maintained a higher water content than the tilled or the control. Now, strangely enough, our top dressing lots maintained a lower water content than the not top dressed. Not really sure what the explanation is for that. That could be sort of some confounding factors, but something that we'll look into a little bit more. Okay, and then finally, looking at leachate. This was, we had the lysimeters in each of the lawns. Just want to kind of show real quick. The gray lines here show our compost lots, and sort of we were basically collecting leachate every month and converting that to a depth in centimeters. This black dotted line is our cumulative rainfall. Okay, so some of these lots had more leachate than rainfall. All right, so compost tended to be, if we look at those lots, they tended to be kind of high. Some of our highest for leachate, and they fell kind of into two groups. One that's sort of a little bit lower here. The tilled tended to be, we had a few that were high, okay, and then more of a group that's down here, so less leachate. And then our control lots, we had two that were basically kind of higher, with the remainder being very low. And in many cases, our control lots, we actually didn't collect, there wasn't a sample to collect. So there's a couple things that are leading to this. Number one, if your soil is compacted, you're not getting infiltration, so you're getting a lot of runoff, and so that's not recharging the ground. So we're not getting leachate in those situations. But if our soil is pretty wet already, or it's holding on to a lot of water, then when we get a rainfall event, we are likely going to be transferring a lot of that water into leachate. Okay, so if we look at the average monthly leachate depth, we saw that the compost was significantly higher than our control here and here, with tillage not kind of splitting the difference, kind of straddling the fence there. Okay, so we had more leachate volume that's coming from the compost. Top dressing, basically even across those. All right, so so looking at loadings, one of the things that we also found is that the concentrations were not significantly different between the compost, tilled, and control lots for our nitrogen or phosphorus. They were basically the same across those treatments. Okay, so the difference that we see here with our loadings, and looking at the overall loadings in this case, the loadings were driven by volume. Okay, in most cases here. So you can see that we have very little leachate loading from our compacted soils. We had, substantially more leachate that's coming from our tilled soils. Okay, so maybe we have a deeper root zone, but it's not really, doesn't have that organic matter to kind of hold on to the water. So it infiltrates a lot of water, but then leaches it out. And then we have our compost amended sites here. So we do have, between our compacted and our compost amended lots, there is a concern for potential nitrogen leachate. Now, we did a follow-up study, and there is sort of there is a pulse of nitrogen that comes out when you initially incorporate. Some of that nitrogen is going to continue to be there in the soil and leach over time. However, this is really driven by the substantially higher volume of leachate water that's coming through the amended soils. And so if we think about sort of the driver for that, I should kind of pop that up there. If we think about the driver for that, again, we have excess water going on to the landscape. The aspect that we have control over here is the irrigation. And so if we go back through the factors here, we had higher soil moisture in the compost amended lots. We had greater leachate, but not greater concentrations. So we're dealing with a volume issue. So we had asked folks to reduce their irrigation by 25%, and several of these that actually reduced it even a bit further So it's an indication that we actually aren't reducing the irrigation enough in some of these cases. Okay. So to kind of just wrap up some of the overall conclusions from this OTO study, the runoff here, we did find that the compost amended lots had lower runoff. So we had greater infiltration, leading to greater soil moisture, greater leachate. But there were no significant differences in the concentrations or the loadings from the runoff aspect. In the root zone, as we kind of showed, the compost had significantly higher volumetric water content, and some of the amended homes actually reduced their irrigation run times from 25% reduction to a 55% reduction. With groundwater, again, just to reiterate, we're looking at a volume issue, not really a concentration issue, that the 25% was conservative. So we need to look at ways to reduce that even further. All right, so at this point, what are kind of some of the remaining questions that we had? One is, this 25% reduction seems conservative. How much can we actually reduce the irrigation by? It's sort of a question we were kind of getting. Also, compost itself does have nitrogen and phosphorus content, when you incorporate it or introduce it to the landscape. Do we need to be incorporating at 4 cubic yards per 1,000 square feet? Or can we actually reduce that compost and still get reduce that compost rate and still get a lot of the benefits from it? And then, we've worked with several compost producers, but ideally, as IFAS, I think that it would be best if we understood sort of the physical or chemical characteristics of the compost and could suggest to producers, hey, here are the characteristics that you need to have to basically meet or get this type of performance out of the compost incorporated into the soil. So we wanted to kind of compare, do the compost characteristics kind of matter? And this really comes down to an availability of compost material and the quality of the compost, which I'll get into kind of later on in the talk. So we started this study at Citra, kind of looking at these 3 factors, looking at irrigation rates, looking at amendment rates, and different types of amendments. So we had 120 plots here that we started this study in August of 2019. And you can see here on the left, this is sort of where we put in sort of the different amendment rates. You can see some of the lots look, you can tell they're different shades of gray. These are some of our unamended or control plots here. And then, just after sodding, in this case, we were using St. Augustine grass. And then we didn't get to really implement the study, the irrigation rates, for a couple of reasons until June 2020. Number one is, well, COVID. And the other one was that it took a while for the turfgrass to actually green up and get going in the spring of 2019. So the combination of a late sort of green up and the COVID travel restrictions, we weren't really able to implement the study fully started until June. And we had sort of some dry periods in May. We typically have sort of a mini drought in May and then into June a little bit. And so you can see a little bit of the gradation here for some of our plots. By September, we had a pretty wet period in August and in September here. So there's very little difference here. All the plots were looking really good. And then you can see, and you'll see this in some of our later graphs, that you can tell that December, everything's gone dormant, shut down for the winter. All right, so we had 2 studies actually that were going kind of intermingled, and you'll see sort of how they kind of intersect here in a moment, hopefully. The first study was, we took 48 of these plots, and these are the ones that are in white, and we had basically 4 amendments, 4 amendment treatments, I should say. One's a control, and with the control, we didn't till the soil or anything. We left it compacted. And 3 of the commercially available products. We've anonymized these here as A, B, and C. And you'll see that the numbers here in the treatments, for example, N is our null, A is the compost amendment, 75 is the treatment that, or the irrigation rate, 75% of the, these are the 75% of the IFAS irrigation rate, 1, 4, 2, 3, 4, 1, 2, 3, and 4 being our replicants. We also had 3 rates here, where we had high being 4 cubic yards per 1,000 square feet, moderate being 2 cubic yards, and low being 1 cubic yard. And we had 4 replicants. So data collection, was basically at the beginning and the end of the growing season. We took soil samples from each of those plots and collected them for analysis. We looked at sort of the relative bulk density, the soil organic matter, pH, nitrogen, phosphorus. I'll show you some of those results closer to the end of the results here. We also wanted to look at sort of more weekly what was happening with the turf quality. So we took weekly turf quality ratings and then also looked at sort of the water balance. What's happening with the water in the soil? Are we kind of in a drier period, a wetter period? What's happening? So we looked at measuring weekly irrigation, rainfall, and evapotranspiration parameters. And so we summed this, or kind of summarized it, by looking at the monthly values that I'll show in a moment. We use the National Turfgrass Evaluation Program to rate the turf quality. It's a standardized test to ensure that we have basically turf quality scores that are consistent. So here you can kind of see the range of what we were seeing, kind of a 3 to an 8. Usually, or the full score is from a 1 to a 9. We didn't really have a 1 or a 2. We were trying to avoid that. We didn't want our turf grass basically dying completely. And then a 9 is basically a perfect lot. For the NTEP, they use a standard of 6 as the minimum acceptable quality. We lowered that to 5 to basically kind of capture that homeowners might allow a slightly lower quality than maybe a professional area or something like that. So just to give it a little bit more, but in reality, you'll see that there is you'll see that the threshold kind of, in some cases, it doesn't matter so much. It's really just looking at the relative quality. So starting out here, I know this is sort of a busy graph here. I'll walk you through it. Here on the left, we have our monthly average turf quality scores. 9 is the max. We get down to 2.5 or 3. Here's our monthly turf quality scores for amendments A, B, and C. And this is the data for the 25% reduction. This black line represents essentially the wetness or moisture, or sort of the water balance. Okay, so this is the monthly total rainfall plus irrigation depths minus the evapotranspiration for the crop, for the turf grass. Okay, some things should pop out to you or kind of notice. Number one, over the entire period, none of our plots really dropped below that minimum 5 that we had set at the beginning. We did have sort of our controls dropping below 6. Initially, we had sort of a drier period in June and July where it was getting a little stressed. But then when we hit the wetter period of August and September, we were really kind of, everything was looking pretty close to each other. Among the different amendments, we really don't see much of a difference, particularly when we get into September, October, and November. We see maybe as much as half of a rating point difference between B and then the other 2, A and C, which seem to be very similar to each other. And then you can see in December, this is when we hit dormancy and it drops off. Now let's look at sort of what happens as we reduce the irrigation further. So the next one here is looking at 50% of the IFAS irrigation. And in this case, we can see that our turf quality scores are dropping a little bit more. We still haven't had our controls drop below 5, but we are below 5.5. Okay, still very similar results here, where our overall scores have dropped slightly based on the lower irrigation amount. However, we're still, maybe within half of a turfgrass score of other amendments. So not a big difference between these. And you'll notice that this black line drops with our irrigation as well, because the irrigation is dropping, so the overall water availability drops as well. Getting now down to 75% reduction, you can see that we're still maintaining, in many cases, our control lots are still kind of maintaining pretty good turf quality in this case. Our amendments are, still are having having a greater turf quality than the control. Now we're getting to where these amendments are having more like closer to between half and one full turf quality point difference between the control. And the difference between the amendments and the difference between the amendments themselves it kind of differs by the year. You know, sometimes during the year we had the B amendment was the best. Other times it was beat out by the A amendment here, and the C amendment, were kind of very consistent across here. Okay. Now going to the worst case scenario where we had basically non-irrigated plots, we've added stars here to actually indicate situations where the number of our 4 replicates that had to be put on basically recovery irrigation. So a plot, one of the individual replicates, basically the turf quality dropped to 3 and at some point, and so we put it on a recovery irrigation or reestablishment period so we wouldn't lose the plot completely. What you'll notice is that during this June to September timeframe, at least one of the plots in each of the amendment treatments had to go onto that recovery irrigation. Now, 2 of them, A and C, only had one of the 4 plots that had to go on, and actually one of the controls never had to go on that recovery. However, all of our plots in July had an average turf quality that was below our acceptable level of 5. And most of them were below that level in August as well. Once we started getting into the wet period and of September, then we started to see a better quality and recovery. But we weren't able to really, so far it doesn't look like that's feasible to go without any irrigation and maintain acceptable turf quality, at least during this time period. December, you can see that we had sort of a drop off as well as it went dormant. Okay, let's touch on sort of the next study. This here, we were looking at the amendment type and irrigation. And I believe I may have had these switched where the gray is these are the white plots and the gray ones were for study 1. So here we have sort of our amendment and our irrigation rate and the replicate here. 6 amendments here, control, 5 commercially available. So we use A, B, and C, but we also had 2 additional ones that we included here. We looked at 3 irrigation rates, the 75%, 25%, and 0, and amended. I apologize. I've got these kind of switched up here. I apologize. Well, let me walk through it here because the introduction, I totally botched it. My apologies. So in this case, we're looking at sort of the different amendment rates, 1, 2, and 4 cubic yards per 1,000 square feet. And so this is looking at sort of the turf quality for amendment A and the rainfall irrigation minus ET on the y-axis on the right. What you can kind of see is, number 1, there's a benefit, a significant benefit to having any compost incorporated. So we see sort of 1 cubic yard per 1,000 square feet has a jump over, basically the control. But then we have sort of a less of an increase from 1 to 2 and then 2 to 4. Kind of a minor increase there, not as much improvement. When we look at sort of the other amendments, we see sort of a similar trend where essentially there's a benefit to having a little bit with our turf quality, but there's sort of a diminished returns as we go up to the full 4 cubic yards per 1,000 square feet. You can see here initially there's a big benefit with 4 cubic yards per 1,000 square feet, but then once we get up to the August and September time range, there's not as much of a difference, particularly between 1 and 2. 4 kind of still retains a lead, but you'll see in some of these where 4 is a little bit higher, but if you were to kind of see these lots side by side, then you likely wouldn't be able to tell them the difference. Okay, so we do tend to see a little bit of an impact from 1 cubic yard, a little bit more from 2, and then a little bit more from 4, but it's pretty small incremental differences overall. D, kind of the same thing overall. where we have, a little bit of an increases the turf quality, but not all the way. And same for our Amendment E. So looking at some of the soil properties, just to kind of summarize this for us, the bulk density, what we're seeing here on the left, we have spring 2020 and then fall 2020 on the right. This is in the springtime before we had actually applied the irrigation treatments. And you can see that there's not as clear of a relationship between our 1, 2, and 4 cubic yards as the effect on the modified bulk density we collected here. But as we get into the fall, we actually start to see that relationship tends to be a little bit more clear, where as we increase the amount of compost, we actually decrease the bulk density a little bit more, to sort of a stronger relationship there. As we go into organic matter, we see sort of a similar trend. We see that there is a fairly linear relationship between our incorporation rate and our soil organic matter, which is what we would expect. Compost is made up of a lot of a good source of organic matter. But we also see that these, especially with the 4 cubic yards, that the organic matter is actually increasing over time. So instead of it actually burning off, it's actually trying to kind of build this up a little bit more on its own. We saw this also in the model home study, where the organic matter tended to increase over time as well, and we would see it kind of actually increasing in the lower subsoils too. So the total nitrogen here, total Kjeldahl nitrogen, we see that there's a relationship here between the incorporation and the amount of incorporation and the total Kjeldahl nitrogen. Not a lot of difference between the amendments themselves, but we do see that there is sort of a separation and sort of a stretching, if you will, of that relationship at the end of the growing season, where it's actually retaining more of the nitrogen, or it's building up organic nitrogen in the soil, in the root zone. Looking at soil phosphorus, we see similarly, and it's more like, and this is the source of the phosphorus here is coming from the fertilization regime that was being done at Citra. But we see sort of an initial incorporation of phosphorus, pretty small, but pretty clear relationship that as we increase compost, we're increasing the phosphorus. And then we see that it's actually increasing much more, particularly for A, B, and C, as we after the growing season. So phosphorus is going down. It's either getting bound up in the compost and in the soil, or it's getting taken up in the plant and then basically retained in that soil there. So kind of a summarize here, preliminary results here. This is only basically 6 months of research, where we're getting from June until December. The second year of the study has just begun. We just collected the beginning of the growing season soil samples in February. What we kind of summarize, we've seen essentially negligible differences among the products. We're not seeing that there's a significant difference between any of them specifically. And I think that there's a couple of different reasons that could be the case, but I think it largely has to do that they're all doing really good things for the soil, and we're not seeing measuring the characteristics that may be separating them in some ways. In some cases, more is better. So we did see some benefits from going to 4 cubic yards per 1,000 square feet over 2 and 2 over 1. But it seems to be that 1 to 2 cubic yards, those were pretty similar. And, we may see that depending on how they persist into next year, we may see that that we could actually reduce the amount of compost that we need to incorporate into the landscape, which would reduce the amount of nutrients that are being introduced as well. We also see that 50 to 75% reduction in irrigation could be a possibility here. We definitely saw that 25% was feasible. We saw that with the On Top of the World home study. And now here at this plot scale, we're seeing that 50 and 75% seem to be holding on pretty well. We'd like to see, obviously, a second year of data to kind of show that it's persisting or these results continue. So we'll see hopefully more next year. Just to kind of transition a little bit now into sort of some of the guidance documents that we have. We developed this guidance document in partnership or kind of in coordination with the Florida Department of Environmental Protection with an idea that, okay, we need to kind of provide some instructions or guidance to the development industry or the landscape industry so that they have the knowledge to make the assessment with whether to incorporate compost, or as I'll mention in a moment, sort of being able to select appropriate compost to include in the landscape. So we kind of broke it down into 3 parts that I'll go into in a moment. We also had this reviewed by industry and academics and extension folks. So tried to get some good eyes on it to provide some input and review for us. So the first part kind of goes over kind of what I started out with here, kind of looking at sort of why do we end up with basically poor soil quality in the urban environment. Part of it is that the material that's brought in as fill dirt is not of high quality. Oftentimes, it doesn't typically have very high organic matter or nutrients to provide to the soil, to the plants. And then we have the aspect of compaction. And so then trying to grow landscape plants in there is not very conducive. All right. The second part goes into organic soil amendments. And so we're doing a little bit more than just compost here. We do kind of address things like malorganite and biosolids. We also kind of go into the composting process so that there's an understanding of, there's different feedstocks and how that can kind of impact the end quality or the end makeup of the material. One of the aspects that we want to focus on too is just the understanding that not all compost is compost. So I've tried to do composting in my backyard before I got into, many times over the years before I got into this project, thinking that, oh, well, I can compost, just kind of, put all the leaves and the vegetation material, put some food scraps back there, turn it every once in a while, maybe once a year. And then, yeah, that's compost, right? Well, not quite. And the producers of compost have a very technical process, and there's very strict standards that the material has to actually meet, whether it's, getting a disinfection or, pathogen inactivation, but also looking at, the maturity and complete breakdown of the product. A couple of kind of just 2 key things to remember here is if you can tell what the compost was, what the feedstock was, that's not mature material. And secondly, if you use immature material, you're likely going to do more harm than good by incorporating that or applying that to the landscape. Essentially, the immature material will have too much carbon. And so the bacteria in the soil will basically only be limited by nitrogen, and they'll strip them or basically steal the nitrogen from the vegetation, basically stressing the plants out. And then part 3 here, we go into the kind of an assessment of the soils, the characteristics for the compost, characteristics for the soils, and so that you understand sort of what's going into the integration or the combination here. One of the things that we're kind of using as a recommendation is if you find a material that is made by the U.S. Compost Council, that is certified by the U.S. Compost Council with the Seal of Testing Assurance, STA, that is going to, from everything we've seen, those materials that meet those standards are likely going to give you be suitable materials for incorporating into the soil. We also kind of include sort of some ranges of some compost characteristics, sort of what you might find in what we've seen in literature versus what the ranges are for the Compost Council and the Seal of Testing Assurance. And then we have sort of a short decision matrix. Some soils may be in good condition. You may just happen upon it where they are good quality soils and may, in some case, may not benefit as much from being amended with compost. It may not be worth it. But in most other cases, we're going to see that the soils that we find on a site are not going to be in such good quality. We also have a field sheet where this boils down the actions and gives sort of a step-by-step process for the turf areas, so that if this is somebody who's actually doing the landscape preparation, they can follow these step-by-step guidance here to make sure they effectively and basically incorporate the product. So we have sort of the preparation of the soil area, applying the compost to the area that's going to be sodded. How do you go about the incorporation of the amendment, making sure that you're incorporating it to a sufficient level, making sure that if you have vehicle tracks that you're kind of mitigating that compaction, things like that. And then after the incorporation, kind of making sure that understanding that it's still going to have to do installation of irrigation lines, and if you kind of want to smooth that surface, so screed it or rake it smooth before you put down the sod, and so we have a good level turf area. We also have sort of some photos here to kind of show some of the critical aspects and to be able to evaluate the incorporation and repair any damaged areas. So for example, there might be washout or compaction or something like that that might occur during the irrigation, during the installation of irrigation or during the construction for one reason or another. If you'd like to download that, I've got a link here and I can post that in the chat after the presentation is over. You can also just search online for guidance for amending urban soils with organic amendments and FDEP, and it should bring up the link there for you. Just kind of wrapping up a little bit here, we also had some interest or some questions about, what about local municipalities requiring this? Is there a guidance or an example ordinance that we could provide for them? So we reached out to the UF Law School and worked with Tom Ankerson and some of his students to basically develop an example ordinance. We worked with them and they reviewed sort of ordinances from around the country. We had some from industry that had been provided, and they also searched sort of the national database and sort of to kind of see how others are incorporating, because that's a big aspect here, is like what part of your code are you actually going to incorporate it here? And so typically this is incorporated into the land development code. And then we have finished the example ordinance. We're writing an EDIS to basically append it to that, and we should have that out fairly shortly this year. If you'd like it in sooner than that, please contact me and I'll be happy to share it with you. Just kind of go through that pretty quickly here. So this is an example that a local municipality could modify to their own local conditions. And we really try to provide that encouragement. They kind of tailor this to what's sort of the issues there and what's critical for their community. So we have the initial basis of the ordinance is sort of the whereas, the finding of fact. These are the facts that we base this ordinance on. So there's that aspect, and there's sort of a page full of that. We have the title here, and sort of this is what we mean by sort of the guidance that's incorporated here. So you can call this however you will, whatever fits sort of your community. We have the ordinance purpose and objectives. So the ordinance is meant to, in this case, improve the function and health of the soils, but also to decrease the amount of water, irrigation, and reduce the potential for fertilizers or other pollution to go into the landscape or go into the watersheds and so forth. We kind of covered the applicability. So there's an aspect there to where would this potentially be, what type of sites, what type of settings would this apply? In this case, we set a threshold of 4,000 square feet or greater. That's kind of up to the local government, whether they want to stick with that or go lower or higher. The compost soil requirements here, basically looking at, we're looking at here, the incorporation needs to be 4 to 6 inches. And right now we still have 4 cubic yards per 1,000 square feet. We may revisit this at the end of this study at Citra, where we're seeing sort of we may not need 4 cubic yards per 1,000 square feet. And then we have sort of compost requirements here that we've included with some characteristics for the requirements of that compost material. We then go into sort of compliance and enforcement. This is always kind of a tricky aspect here. So we went around a lot about sort of, well, how do you go about this? How would you go about enforcing this? So we had to come up with this term, enforcing officer. So that's kind of up to the community, and that's likely going to be someone who is already an employee or part of the local government there that would have to basically sign off or approve that it has been followed. And then we included sort of an aspect of public education, sort of the process for if there is a notice of violation and what those penalties might be. Notice here, for example, with penalties, we didn't specify anything here because I think that's basically really should be left up to the city or county, and we don't want to really make any suggestions there. That's kind of if they want to do that or not. Just some acknowledgments. Several folks from here at UF have helped out with a lot of the research and the work that I provided here. I just get to be the one that kind of presents it. But thank you to all my colleagues, grad students, and people that we've worked with that are municipality or community partners. I probably left some off of there. One of our biggest partners is Philip Heisey at On Top of the World, as well as Ryan McMeekin and Darren Menlin. We've worked with them quite a bit in using the Command product. It's been great working with those guys. Brian Schmalls and David Gruber, they kind of are with a lot of our On Top of the World projects, as well as the Scott's Company for providing, they're one of the providers of some of the compost material that we were testing. And then several funding agencies, the Florida Turfgrass Association, FNGLA, SwiftMud, and Florida DEP have all in various ways supported the work that I got to present here today. So with that, I am going to stop sharing and I am going to turn it over to Mr. Kevin Coyne.
Eban, it's Wendy. We've got a lot of questions stacking up. And would you mind taking a few just before we move too far away from the graphs?
Yeah, I'd be happy to.
Okay. We have a question about the leachate. You showed that it was nitrogen being leached. Could you elaborate on that a little bit more?
Yes. So let me get this. Yeah. Let's see, get everything shared. See, I stopped sharing and then I run into trouble. Let's see here. Where is it? Screen two. There we go. We'll do it. All right. Yeah, so we had whoops, too far. Okay. Yes. So the main thing here was that I didn't include it here, but essentially when we looked at the concentrations of total nitrogen and total phosphorus that were coming from the different treatments here, control, till, and compost, we ran statistical analysis and we did not have any significant differences between the concentrations. They were all essentially very, they kind of overlapped each other in the distribution very closely. Okay, so when we look at the actual volumes, so when we talk about loading and nitrogen loading and leachate here, the loadings here are driven by either concentration, volume, or both. All right. So the volumes here, we see that our compost amended lots were the ones that produced more of the leachate. All right. And so in this case, we're seeing that the loading is driven by volume rather than by difference in concentration. So for example, it's not like we had very similar leachate volumes or leachate depths and the concentration was much higher for one of our treatments versus the other. That wasn't the case. It was the opposite, where we had, the volumes were what actually were different compared to our concentrations. I hope that answers that question there.
I think it does. And then another person asked about the leaching, whether there were any other fertility treatments applied to the non-top dress lots.
Yeah, so each of these homeowners had the option to have a local company maintain their landscape. We tried our best to get either have the homeowners to record whenever they did treatments on their lot, or when their company did. That was of limited success with homeowners sticking to that. And then we tried to contact the landscape companies, only a few of which kind of worked with us to provide us with any information. So we don't have a full, complete record or picture there as far as what was done on the landscape. So I think that also kind of leads to some of the where we didn't have clear differences among some of our lots. It could have been that they had a different landscape company that did something much different. Or we had that one homeowner who basically did his own maintenance and made his lot look like a professional sports field. So there were some confounding factors that we couldn't capture. It's the landscape's a complex system, and we couldn't collect it all, couldn't capture it all, unfortunately.
Okay, so then it would be really difficult to know how much of that nitrogen applied was the top dress, how much of the top dress nitrogen would be then leached, right?
Yeah, we would have it's difficult to show that. The other thing is that we saw, interesting, we did look into this as far as like, okay, we had top dressing in, I believe it was May and September, kind of later in the year, partly, well, COVID hit and that kind of threw off some things with being able to do that. Part of that is that we did look at sort of, okay, the following month after a top dressing application, did we see a spike or an increase in the concentrations or from those lots? And we didn't. So that was also kind of interesting that we see that the soils tended to buffer any leaching of nutrients that may have resulted from the top dressing. We just didn't see that there was a clear spike, in the month that we right after the top dressing.
Okay. All right. Well, you know what? Those are the questions about leaching, and I think those were probably the ones that kind of bubbled up to the top. Why don't we go ahead and get Kevin Coyne going?
Okay, that sounds great.
Can you guys hear me okay?
Yep, sounding good.
All right. Yeah, I don't have a ton of information to share, anything other than, Evan, excellent job. Thank you so much. I think one of the things I wanted to bring the message home today was that, a lot of this came out of working with our stakeholders and our BMAPs who wanted this type of work done, because they were looking for other avenues, BMPs, things like that, for the reduction requirements they have in their BMAP. So this is just another one of these things that we're looking to support into getting more information, more guidance. The guidance that was developed is posted on our website. So this is the type of opportunity that we as a department are looking for from a larger scale. This and others, we're doing a lot of work with Eban and some other IFAS folks on things like green infrastructure, looking more and more into monitoring for that and seeing what benefits we can get. And we appreciate this type of work because it helps us understand what's really going on. That guidance is key when we have a lot of people coming to us to say, how do we do this? Well, we have a nice document, and this ongoing monitoring is going to help us better understand what is going on. I've heard a lot of folks a few years ago saying, well, is this really going to be a benefit? Where are the benefits going to be? And this type of work helps us as a department, as districts and everyone else to do this. So it's we appreciate this, and we continue to go down this path of looking for more information, looking for that wonderful term, tools in our toolbox. We love to use that, but that's where we're heading. As the status quo, we don't think is where we need to be. We need to keep pushing, keep looking for new things. So appreciate this work, and we are always looking for other opportunities out there. So never hesitate to contact me if you're a researcher doing this. This is something that I think is a good starting point. Getting good information, have great information, going to get more. So we appreciate that, and that's really about all I had to say. And I know there might be some other questions to address as we get through here. But thanks again, and we are continuing to be appreciative of this work that's being done.
Awesome. Thank you, Kevin. Yes, we do have more questions, and they are about soils and irrigation. So let's dive right into them.
Okay, go ahead.
One of the questions is the 100% irrigation reduction graphs didn't seem to take in effect rainfall. So during the rainy season, was there not a lot of rainfall that summer, or what were we seeing there?
No, we did have rainfall. That fast. All right, so here we did have rainfall, okay, but essentially irrigation in this balance was 0. So for example, in this graph, what we would see is that we had, when we take rainfall minus the crop evapotranspiration for June, we had a net of 4 inches of water, okay? And then in July, we're down to about 1 inch of water. And then in September, we had, a lot of rainfall. Again, there's no irrigation being applied here. I should say that's not exactly true. We applied irrigation to the plots that had to go on recovery, but those plot scores were not included in the values that you see here. So these are just for the plots that once they made it back to basically an equilibrium turf quality. I think we set that as a 4 or higher. So in this case, in October, we actually had a net loss. We didn't have very much rainfall. We didn't have a lot of ET, but it was enough to basically outcompete the water. We had more ET than rainfall. And then with the November, 1.5 was our net there. So we're not saying that there's no rainfall. It's just there was no irrigation applied. So it's just relying on rainfall here. Okay.
Okay, awesome. And then we have a question about the type of compost that was used and the cost to the developer, and was there any potassium in that compost?
Oh, that's a good question. I don't know on the potassium. I would have to look into that. When we look at the on top of the world studies, those were both looking at those both used the command compost. And those were screened to, I believe it's 1/4 inch is what is incorporated there. As far as potassium, I'd have to look at the breakdown. I assume that's not one that I'm usually looking at. I'm usually looking at the nitrogen, phosphorus, and carbon. But I assume there's some amount of potassium that's in there.
Maybe, potassium is important for
Yeah.
stress and turf. So I
Yeah.
think that's probably why they're thinking about that.
Yeah.
And the cost involved, is it cost
Yeah.
prohibitive for the developer, or would it be something that they would be easily adopting?
Some of these are. It's we're working on sort of a cost benefit analysis tool to kind of take into account the different amounts of water reduction and how that might be passed on to the homeowner. And then looking at what that initial cost is. To pull up, I always have to remind myself of what the values are. If you give me just a moment, I can pull that up, what those values are.
Okay, well, I really like this image here. You can really see the difference.
Here we go. All right. So the values we use, it's going to vary a little bit based on transport costs and labor to incorporate. We see, for example, you might, depending on how much area you use, it might be as low as $1,000 per lot. But if you're doing the entire lot, it might be more along the lines of like $2,000 per lot. So that's sort of the range that we're looking at for typical sort of 1/4 acre land development with 2,000 to 3,000 square foot. 2,000 to 3,000 square feet of impervious cover. So that's not the inside of the home, but also looking at your driveway, your sidewalks, leaving about 7,000 for pervious, and depending on how much of that you use for landscape or versus sod, and how much of that you do for amending or not. So looking probably in that range of $1,000 to $2,000 per lot, depending on how much of that lot you're going to do.
Oh, wow. Okay, good. Thank you for pulling that data. And Ryan is wondering about the existing soil types, like in the Claremont soils. Would they have a much more different water holding capacity compared to the citrus soils? So would there be a difference in water holding depending on how much compost was amended to the site?
I think that, based on my experience with those Claremont soils, I mean, they seem to be fairly high and dry as well. Granted, they may not be, they're kind of the sugary sands. Granted, they're not, we're not in a karst area, and so I'm not sure how deep those sands go before it hits sort of maybe a limiting layer of if there's a clay layer down there. But I would expect, based on the soil texture that we see there and what we've seen on top of the world and at Citra, that we'd expect to see very similar results there.
Yeah, yep. And then, someone has asked about the IFAS recommendations suggest just doing top dressing with compost and, putting maybe some compost in the bottom of the plant pit. This is contrary, what we're talking about is kind of contrary to current IFAS planning guidelines. So you're breaking new territory here. So Howard, how do you see those guidelines changing?
Well, I think that, we're trying to, and I think I caught this question a little bit. And one aspect is we are trying to kind of make up for the poor quality of fill material that's oftentimes in that landscape. When we're talking about, and we're trying to say, you don't have to amend the entire bed area. For example, if you're not doing sod, if you're doing just landscape beds, work it into the planting, the root ball, that sort of, that immediate area of the plant that you're putting in the ground. That can save on material cost and on the labor cost for incorporating it. So I'm not sure that we're actually kind of, I'd want to kind of see where that recommendation is in conflict. I don't think that it wasn't intended to change any kind of recommendation that we have. It's just sort of how compost could be used in the areas that are not being amended for lawns, for turf areas.
Right. So this is a different part of the landscape and a different type of landscape.
Right.
Right. Okay. Kevin had a question in the chat box, and he did answer it in the chat box, but I would like him to elaborate a little bit more on it too, Kevin, if that's okay. So the question was, do the nutrient leaching data that Dr. Bean just presented give you concern for crediting these practices for water quality benefits?
Yeah, I think it's a spot on question that, yes, we have to look at the whole suite of what's happening before we do any sort of crediting at this point. The data, I think, shows that, if it's volume driven, then we have to address the volume, obviously. So I think, yes, that is going to be part of that whole equation. We haven't done that yet at this point. We're starting at this, and I think as we get more information, and if someone comes to us with a project like this, that's going to have to be a big part of it. So I would say, yes, it's going to at some point.
Fantastic. Good. Well, I want to thank you all for attending, and thank you both for excellent presentations and support. I think it was a great consolidation presentation on the studies that you all have been doing. Dr. Bean, it's really interesting to see this work continue to go on and keep getting better. So I really appreciate you being here today. And thank you for presenting to the Urban Landscape Summit. And as a reminder to all the participants, the material has been recorded and will be up on the website and the YouTube channel for viewing again. So thank you all, and I will say goodbye for today. Thank you.
Thank you all.
Thank you.